Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to my channel Learn Mathematics by Abid Hussain. Hope you will be fine. Today we are going to solve exercise 3.6. Let's move on to exercise 3.6. Part number 14, question number 1. Let I is equal to integration of x sine inverse of x d of x. Here we have two functions. First is algebraic, which is x, and second is inverse function, which is sine inverse of x d of x. Integrating by parts. First function, here we take u is equal to sine inverse of x, mean first function is u, and second function v, which is equal to x, v is equal to x. So I is equal to first function as it is, applying by part integration formula. First function as it is means sine inverse of x as it is, dot mean multiply. Integration of second function, which is x, integration of x is x squared divided by 2, minus integration into integration of second function, which is x squared divided by 2, second function is x, and dot mean multiplication. Derivative of first function is here sine inverse of x, so derivative of sine inverse of x is 1 over square root of 1 minus x squared d of x. Next, multiplying x square upon 2 by sine inverse of x, we get x squared divided by 2 sine inverse of x plus plus, here we take plus and this minus shift from inner function. At this sign of minus we write plus, and here we write minus, because plus minus minus, again this function become this one as. Now x squared divided by 2 sine inverse of x as it is, plus 1 by 2 as it is, integration of 1, here adding 1 and subtracting by 1 in a numerator, because in denominator we have square root of 1 minus x squared, and in numerator we have only minus x. To make such type of term, we add and subtract by minus 1. Okay, x squared divided by 2 sine inverse of x plus 1 by 2. Integration of dividing this square root of 1 minus x squared by this term 1 minus x squared, and also by minus 1. Okay, minus 1 upon square root of 1 minus x squared. This, and when we move 1 minus x squared power 1 by 2 from denominator to numerator, its power become negative, and this 1 minus x squared power is 1, and this 1 minus x squared power will become minus 1 by 2. Taking when these two same terms are multiplied, their powers are adding, and taking LCM of 1 minus 1 by 2, we get 1 by 2, which is equal to square root of 1 minus x squared minus this terms as it is. Next, taking integral on both terms, first term 1 by 2, integration of square root of 1 minus x squared d of x minus 1 by 2 square integration of 1 over square root of 1 minus x squared. Okay. I is equal to x squared divided by 2 sine inverse of x plus 1 by 2 I1. Here we take this function is I1, this function, this whole function, sorry, just this function is a I1. Okay, minus 1 by 2, and this whole function is which is equal to integration of 1 over square root of 1 minus x square is equal to sine inverse of x. This is called equation 1. Now I would like to solve this I1, mean integration of square root of 1 minus x square. Okay, where I1 is equal to integral square root of 1 minus x square, this one. Okay, from previous exercise we know that suitable substitution we have already learned. If square root of 1 minus x square, then put x is equal to sine theta, a square minus x square as it is. Okay, at the place of a here 1. Okay, the x is equal to sine inverse of theta, which implies that then taking differential, we get d of x is equal to derivative of sine x is cos x, cos theta, sine theta is cos theta d theta. I1 is equal to integration of square root of 1 minus x sine square theta. At the place of x we put sine theta, sine square theta, and at the place of dx we put cos theta d theta. Okay, as we know that 1 minus sine square theta is equal to cos square theta. Cancel this square and square root, we get just cos theta. This cos theta multiplying, then we get cos square theta, integration of cos square theta d of theta. We also know that from previous exercise, cos square theta is equal to 1 plus cos 2 theta divided by 2 and theta. Next, taking 1 by 2 constant outside the integral, then 1 plus cos 2 theta. Now integrate this 1 and cos 2 theta. Okay, integration of 1 is theta, plus integration of cos 2 theta is sin 2 theta divided by 2 plus constant of integration. Now at the place of sin 2 theta we write 2 sin theta cos theta, as we know that from double angle identity sin 2 theta is equal to 2 sin theta cos theta divided by 2 plus constant of integration. Okay, theta as it is plus 2 and 2 cancel out, sin theta as it is, at the place of cos theta we write square root of 1 minus sin square theta. Okay, this whole function and convert into sin theta, and we know that sin theta is equal to x. We let here this, at the place of sin theta we again put x. Now next, here 1 by 2 at the theta place of theta we write sin inverse of x. How? Look here, just okay, here we put x is equal to sin theta, and when we want the value of theta, then theta is equal to sin inverse of x. So we put the value of theta, which is equal to sin inverse of x here, plus at the place of sin theta we put x, and square root of 1 minus at the place of this sin theta is x square plus constant of integration. Now putting this I1 value in equation number 1, which is I is equal to x square upon 2 sin inverse of x plus 1 by 2 into the value of I1, which is this one, 1 by 2 sin inverse of x plus x square root of 1 minus x square plus a constant of integration, minus 1 by 2 sin inverse of x as it is, and which is also equal to x square divided by 2 sin inverse of x plus 1 by 4, 1 times 1, 2 times 4 sin inverse of x plus 1 by 4 this one, x square root of 1 minus x square, and plus 1 by 2c minus 1 by 2 sin inverse of x as it is. Next, I is equal to x square divided by 2 sin inverse of x as it is, minus 1 by 4 sin inverse of x as it is, plus 1 by 4 x square root of 1 minus x square plus 1 by 2 and c, which is also another constant, which is also called c prime c1 any constant. Okay, because constant multiplied by constant is again a constant, which is required solution. Next, question number 1, part number 15, which is let I is equal to integration of e power x sin x cos of x and d of x. Here we have this function is exponential function, and these two function are trigonometric function. Here we consider these two function as a one function, and this e power x exponential function as another function. Okay, and which is equal to we know that from double angle identities, sin 2 theta is equal to 2 sin theta cos theta, 2 sin theta cos theta. Here sin theta cos theta available, but 2 is not appear in this question, so we divide and multiplying by 2, and at the place of 2 sin theta cos theta we write sin 2 theta, since sin 2 theta or sin 2x is equal to 2 sin x cos x. Integrating by parts, I is equal to 1 by 2. Okay, first function as it is, here we take e power x as a first function, and v is second function, which is sin 2x as a second function. Okay, integration of sin 2x is minus cos 2x divided by 2, minus into integration of second function, which is minus cos 2x divided by 2, and derivative of first function, which is e power x, is also equal to e power x d of x. We know that derivative of exponential function is again exponential function, which is equal to 2 times 4 minus 1 by 4 e power x cos 2x plus minus plus 1 cos 2x 2 times 4 integration of e power x cos 2x. Here we have again two functions, which is first one is exponential and second one is trigonometric function. Now we again integrating by part. Okay, minus 1 by 4 e power x cos 2x as it is plus 1 by 4. Now applying by part integration, first function e power x as it is, integration of cos 2x which is equal to sin 2x divided by 2 minus 1 by 2 into integration of e power x is as it is, again e power x, and derivative of cos 2x is sin 2x divided by 2, this 2. Okay, minus 1 by 4 e power x cos 2x plus 1 by 4 e power x into sin 2x divided by 2 minus I. This function is called minus 1 by 4 e power x cos 2x as it is plus 4 2 times 8 e power x sin 2x and 1 by 4 minus 1 by 4 multiplied by I, where I is this function. Here we take this function is equal to I. Okay, now solve which is equal to equation 1 from question. We let I, which is equal to integration e power x sin 2x. So we put the value of this function which is equal to I. Shift this minus 1 by 4 I from right to left. We get I plus 1 by 4 I, which is equal to minus 1 by 4 e power x cos 2x plus 1 by 8 e power x sin 2x plus x as it is. Now taking LCM is 4i plus I, 4i plus 1i is equal to 5i divided by 4, which is equal to minus 1 by 4 e power x cos 2x plus 1 by 8 e power x sin 2x plus c. Okay, now this 5 is multiplying then dividing when we want to prove the value of I. For this we cancel this 5 and 4, and for this we dividing whole function on both sides by 5, then this 5 and that 5 is cancel out, and multiplying both sides by 4, then this 4 and that 4 is cancel out. We get I, and this 1 by 5 4 cancel, e power x cos 2x plus 1 by 4 and 2 4 2 times 8 and 8 5 times 15. This 5 is multiplying here, and from when we shift from left side to right side, which is dividing on each term of right side. Okay, next, which is required solution of our problem. Part number 8, which is same to previous part number 16, which is same to part number 15. So it's for you. Now do yourself. Next, part number 17, which is I is equal to integral x cos square x d of x. At the place of cos square x we put 1 plus cos 2x divided by 2. This 2 is constant, so we shift from outside the integral 1 by 2 integration of x 1 plus cos 2x d of x. Okay, multiplying this x d of x and taking integral on each terms. Okay, 1 by 2 integration x dx plus 1 by 2 integration of x cos 2x d of x. Integration of x is x squared divided by 2 plus 1 by 2 as it is. Here we apply by part integration. First, this function is algebraic function and this one is trigonometric function. We take algebraic function as first function, which is x as first function as it is, integration of second is cos 2x, integration of cos 2x is sin 2x divided by 2, minus integration into integration of second, which is sin 2x divided by 2, and derivative of first is x, and the derivative of x is 1. Next, x square divided by 4, x square 2 times 4 plus 1 by 4, this 2 and this 2 is equal to 4. X dot multiplied by sin 2x minus plus minus 1 times 1 2 times 4 integration of sin 2x d of x. These all terms are same. Minus 1 by 4, we know that integration of sin 2x is minus cos 2x divided by 2. X square divided by 4 plus 1 by 4x multiplied by sin 2x as it is, this minus and minus plus cos 2x divided by 4 2 times 8 plus c, which is the required answer. Question number 1, part number 18, which is let I is equal to integration x sine square x d of x. At the place of sine square x we put 1 minus cos 2x divided by 2. This 2 is constant, so we shift from outside the integral 1 by 2 integration of x into 1 minus cos 2x d of x. Okay, multiplying this x and d of x and taking integral on each term. 1 by 2 integration of x d of x minus 1 by 2 integration of x cos 2x d of x. Here we have two functions. First function is algebraic, second is trigonometric. So first we take algebraic as a first function, means u is equal to x and v is equal to cos 2x, means second function is cos 2x. Okay, integrating by parts, I is equal to 1 by 2 x square divided by 2 minus 1 by 2 this x square. Integration of x is x square divided by 2 minus 1 by 2 as it is. Here we apply by part integration. First function x is as it is. Integration of cos 2x is sin 2x divided by 2 minus integration into integration of second function, which is cos 2x is equal to sin 2x divided by 2, and derivative of first is derivative of x is 1 d of x. Next, x square divided by 4 minus 2 times 4 x sin 2x plus this minus and this minus plus 2 times 4 1 by 4 into sin 2x. And we know that the integration of sin 2x is minus cos 2x divided by 2. This 2 multiplied by 4 we get 8. These all terms are as it is. Now part number 19 is let I is equal to integration natural log of x whole square. We know that integration of natural log of x is not possible, so here we take another function, which one is 1. Okay, now applying by part integration, first function is here we take natural log of x square as a first function and 1 as a second function. Okay, first function applying by part integration, first function as it is, and integration of second function. Integration of x is 1 is x minus integration into integration of second, which is at the integration of 1 is x, and derivative of first. Here we apply power rule. Power come before the function and subtract 1 from power. Power is 2 minus 1 is 1. Okay, and derivative of first and derivative of inner function. Inner function is the natural log of x, so derivative of inner function, which is equal to 1 by x d of x. This x and this x are cancelled out. X natural log of x square minus 2 into integration of natural log of x d of x. We know that integration of natural log of x is not possible. That's why we again let a function another function, which is 1. So here 1 is another function. So x again integrating by part, x natural log of x square minus 2 as it is. Applying by part integration on these two terms. Other term is here 1. Okay, first function we consider natural log of x. First function as it is integration of x. Second function is x. Integration of x is second function is 1. Integration of 1 is x minus integration into integration of second function is 1. Integration of 1 is x, and derivative of first is natural log of x, and derivative of natural log of x is 1 by x. Okay, cancel this x and this, we get just this d of x. X natural log of x whole square minus 2x natural log of x plus 2, and integration of this dx is 2x plus constant of integration. Part number 20 is let I is equal to integration of natural log of tan x secant square x d of x. Here we have two functions. One function is natural log of tan x and second function is secant square x. We take natural log of tan x as a first function and secant square x as a second function. Okay, integrating by parts, first function as it is, which is natural log of tan of x, and integration of second function. Second function is secant square x, and we know that integration of secant square x is tan x minus integration into integration of second function. Second is secant square x, and integration of secant square x is again tan x. Dots are multiplied by derivative of first function is natural log of tan x. We know that the integration derivative of natural log of tan x is 1 over tan x, and again derivative of this function, which is tan x. Derivative of tan x is secant square x. This tan and tan is cancelled out, and then d of x as it is. Okay, tan x natural log of tan x minus integration of secant square x d of x, and we know that the integration of secant square x is tan x. Okay, Next part number 21. Let I is equal to x sine inverse of x divided by square root of 1 minus x square d of x. Here first of all separate these functions sine inverse of x and multiply by 1 upon square root of 1 minus x square into x. Okay, shift this function from numerator to denominator, its power will become negative. Okay, minus 1 by 2 sine inverse of x into 1 minus x square whole power minus 1 by 2 minus 2x. This minus 2x is the derivative of this inner function. The inner function is 1 minus x square, and derivative of 1 minus x square is equal to minus 2x. Okay, here we have two functions. This one is inverse function and this whole function is a algebraic function. Okay, integrating by part, minus 1 by 2 as it is, first function as it is, sine inverse of x is as it is, and integration of second function, integration of second function 1 minus x square minus 2 power minus 1 by 2. So when we integrate, then adding 1 in power and dividing by same function. Okay, minus integration into integration of second, which is 1 minus x square or power minus 1 by 2 plus 1 and divided by minus 1 by 2 plus 1, and derivative of first function, and we know that the derivative of sine inverse of x is 1 over square root of 1 minus x square. Okay, minus 1 by 2 as it is, sine inverse of 1 minus x square whole power 1 by 2 divided by 1 by 2 minus integration 1 minus x square whole power 1 by 2 divided by 1 by 2 into 1 over square root of 1 minus x square. This 1 minus square root of 1 minus x square and this one is cancelled out. We get just this 2 outside the integral. Okay, minus 1 by 2 into 1 minus x square, this one. Okay, whole power 1 by 2 sine inverse of x minus 2, this 2 should move from denominator to numerator. Okay, into d of x, and we know that integration of d of x is x, which is required solution. Question number 2, part number 1. Let I is equal to integration of tan 4x and d of x, which is can be written as integration tan 2x multiplied by tan 2x, mean tan square x. Sorry, tan 2x, it's tan square x multiplied by tan square x and d of x. Okay, integration of tan square x as it is, at the place of tan square x second one, we can write secant square x minus 1. We know that tan square x is equal to secant square x minus 1 into d of x. Multiplying this tan square x by secant square x and by 1, we get tan square x secant square x minus tan square x. Now applying this integral on these two terms, we get integration of tan square x secant square x d of x minus integration of tan square x d of x. Here we can see a derivative of tan x, which is secant square x. This is whole power. We look here only just this tan x. Now derivative of tan x is secant square x, which is available here. That's why we when we integrate such a function whose derivative is exists, then we applying power rule, add 1 by power and dividing by that function. Okay, tan power 2 plus 1 divided by 2 plus 1 minus integration of secant square x minus integration of this 1. Okay, integration of secant square x is tan x, we know that, which is tan x minus integration of x dx is x plus constant of integration. Next, part number 2, which is secant power 4. We can write secant power 4 as a secant square theta into secant square theta. At the place of secant square theta, we use the identity, which is 1 plus tan square, sorry, not theta, here is x. Secant square x is 1 plus tan square x into secant square x d of x. Taking integral on each term, secant square x multiplied by 1 is secant square x, integration secant square x d of x plus integration of tan square x secant into secant square x d of x. We know that integration of secant square x is tan x plus here we can see derivative of tan x, which is secant square x, which is exist here. Okay, that's why we applying power rule when we integrate. Okay, adding 1 in its power, which is 2 plus 1 is 3 and whole divided by 3 plus 1. C is the answer. part number 3 is let I is equal to integration of e power x sin 2x cos x d of x. Okay, we know that the identity is here we applying this dividing and multiplying this whole function by 2, 1 by 2 into e power x 2 sin 2x cos x d of x. We know from trigonometry, if we have 2 sin alpha cos beta, then we can write that is sin alpha plus beta plus sin alpha minus beta. Here at the place of alpha is 2x and at the place of beta is x. So we write sin 2x plus x plus sin 2x minus x d of x. 2x plus x is 3x plus 2x minus x is sin x. Okay, x. Now multiplying this e power x and taking integral on each term, we get 1 by 2 integration e power x sin 3x into d of x plus 1 by 2 e power x is sin x d of x. Here which is equal to 1 by 2 and integration of e power x sin 3x d of x take we I1 and plus 1 by 2 is integration of e power sin x d of x. We taking this function as I2. This is called equation number 1, where I1 is equal to integral e power x sin 3x d of x and I2 is equal to integration of e power x sin x d of x. Solve I1. This I1 solve. How can we solve it? Just take the by part integration. Okay, first is exponential, second function is trigonometric, which is as same as solve I1 and I2 as in question number 1 part number 15 and put values of I1 and I2. Here we at the place of I1 and I2 we get solution. Okay, part number 4 is I is equal to integration tan cube x into secant x. We can write tan cube x as tan square x multiplied by tan x and secant x d of x. At the place of tan square x, we write secant square x minus 1 and secant x tan x d of x. Let or put t is equal to secant x. This secant x is t. We know that the derivative of secant x is secant x tan x into d of x. Putting values here, integration of at the place of secant we put t square minus 1 into this whole function is equal to dt. Taking integral, we know that integration of tan square is tan cube divided by 3 minus integration of 1 is t plus constant of integration. Again replacing t by, where is it, t by secant x. Okay, secant cube x divided by 3 minus secant x plus c. Question number 2 part number 5 is x cube e power 5x d of x. Integrating by part. Here this function is algebraic and this function is trigonometric, exponential function. Okay, now we consider x cube as u and e power x as a v. First function which is x cube, which is same, and integration of second function is e power 5x, and we know that integration of exponential is as it is e power 5x is integration of e power 5x is equal to e power 5x divided by that constant which appear in its power. Okay, which is coefficient of x, which is 5. Okay, e power 5x divided by 5 minus integration into integration of second function which is e power 5x. So integration of 5x is e power 5x divided by 5 and derivative of first is x cube. So we write and the power before the function which is 3 and x power 3 minus 1 is 2. 1 by 5 x cube e power 5x minus 3 by 5 into integration of x square e power 5x. Here we have again x square and e power 5x two function. This is algebraic, this one is trigonometric. Again we applying by part integration. First function as it is which is x square, integration of second function which is e power 5x. We know that integration of e power 5x is e power 5x divided by 5 minus into integration of second function which is e power 5x divided by 5 and derivative of first function first is x square, so derivative of x square is 2x. Okay, now multiplying this 5 3 and this 5 through whole function. Okay, 3 over 1 over 5 x cube e power 5x as it is minus 3 by 25 x square e power 5x minus minus plus 3 2 times this 2 and this 3 3 2 times 6 divided by 5 5 10 25 integration of x e power 5x. okay, again applying by part integration, because here again we have two functions, which is first one is x and second one is e power 5x. okay, 1 by 5 x cube e power 5x minus 3 by 25 x cube e power 5x as it is, plus 6 upon 25 taking common. okay, first function x is as it is, integration of second function which is e power 5x, integration of e power 5x is e power 5x divided by 5 minus integral into integration of a second function which is e power 5x and divided by 5, and derivative of first function first is x, derivative of x is 1. 1 by 5 x cube e power 5x minus 3 by 25 x cube e power 5x as it is, plus the multiplying this 6 and over 25 through whole function, x over 6 over 125 5 25 times 125 x e power x 5x minus 6 1 times 6 divided by 125 into integration of e power 5x. okay, these all term are as it is, minus 6 over 125 multiplied by integration of e power 5x is equal to e power 5x divided by 5 plus constant of integration. Now taking common e power 5x divided by 5, we get x cube minus 3 by 5 x square plus 6 by 25 x minus 6 over 125 plus c, which is required solution. Next, part number 6 is let I is equal to integration of e power x sine 2x d of x. Here this function is exponential and this one is trigonometric, so we take exponential function as a first function. Integrating by parts, I is equal to first function as it is, e power minus x as it is, integration of second function is sine 2x, so sine 2x, integration of sine 2x is minus cos 2x divided by 2, minus integration into integration of cos second function which is minus cos 2x divided by 2, and derivative of first function is e power minus x, and derivative of exponential function is as it is, e power minus x, and then again taking the derivative of its power is minus x, and we know that the derivative of minus x is minus 1 d of x. okay, now next e minus e power minus x 1 by 2 cos 2x as it is, minus plus minus again minus. okay, 1 by 2, this 2 is constant, so we shift from outside to integral sign, integration of e power minus x cos 2x d of x. okay, we see here again two function, exponential e power minus x and cos 2x, again two function, and here we again applying by part integration. okay, again integrating by parts. okay, I is equal to minus 1 by 2 e power minus x cos 2x minus 1 by 2 as it is. Next, first function as it is, integration of second function integration of cos 2x is sin 2x divided by 2, minus integration into integration of cos 2x is sin 2x divided by 2, and derivative of first function which is e power x e power minus x into derivative of power is minus x minus 1. okay, next minus 1 by 2 e power minus x cos 2x minus 1 by 4 e power minus x sin 2x as it is, minus 1 by 4, this 2 and this 2 multiply, then we get 1 by 4 integration e power minus x sin 2x d of x. okay, I is equal to minus 1 by 2 e power minus x cos 2x minus 1 by 4 e power minus x sin 2x as it is, minus 1 by 4 I. This function is equal to I. This function is a given function I is equal to integral e power minus x sin 2x. So we put at the place of this function is I plus 4. okay, now this function is here subtracting, shift from right to left, its symbol will be changed into plus. okay, taking LCM, we get LCM is 4 1 times 4 plus 1 is 5 by 4 I. okay, here we require just I. 5 is multiplying here, when we move from left side to right side it's dividing through all terms, and 4 is dividing here, when we move from left to right it's multiplying by all terms of right hand side. okay, then we get our required solution. Next, part number 7, do yourself as above, okay, which is same to previous part. Next, part number 3 is cosecant cube x. I is equal to cosecant cube x, which can be written as cosecant x multiplied by cosecant square x, which is equal to cosecant cube x. Integrating by part, first function, with both function are trigonometric function, so we can take any one of these, okay. Cosecant function is first function, and derivative of second function, which is cosecant square x, we know that derivative of cosecant square x is minus cot x, okay. Next, here is a minus symbol, not iota symbol, here is a minus symbol, okay. And integration of second function, which is cosecant square x, integration of cosecant square x is minus cot x into derivative of first function. First function is cosecant x, and we know that derivative of cosecant x is minus cosecant x and cot x, okay. Next, minus cosecant x cot x minus plus minus minus, and this minus is again equal to minus. Integration of cosecant x into cot square x, and we know that at the place of cot square x we can put here cosecant square x minus 1. Multiplying this cosecant x and cosecant square x is and minus cosecant x. Now applying this integral sign, and next we can see from the question I is equal to integration cosecant cube x d of x. So here we can put at the place of cosecant cube x integral equal to I minus cosecant x cot x minus integration applying integral on both terms, minus cosecant cube x d of x minus, and that minus is plus, this plus integration of cosecant x and d of x minus cosecant x cot x minus this whole function become I. This I from equation number 1, which is given question is integration of cosecant cube x d of x is equal to I, plus we know that integration of cosecant x, which is equal to natural log of cosecant x minus cot x plus constant of integration. Move this minus I from right to left side, its sign will be changed from negative to positive. I is already here, I plus I is 2I. We know the we want to value of I, so this 2 is multiplying here, and when we shift from left side to right side, it's dividing all terms of right side. We get this solution of our problem. Next, we have question number 3. Show that this relation is equal to this one, okay. Question number 3. Let I is equal to integration e power ax sin bx. Here this function is exponential, and sin bx d of x is a trigonometric function, okay. We take exponential function as a first function and trigonometric function as a second function. Integrating by part, first function as it is, integration of second function, which is sin bx. Integration of sin bx is minus cos bx divided by b, minus integration into integration of sin bx is minus cos bx divided by b into derivative of first e power x. E power x is also equal to e power x. Then again taking derivative of power, we get a. Derivative of ax is a, okay. Plus minus minus e power ax cos bx divided by p, minus minus plus a by this a and this b, a by b integration e power ax cos bx into d of x. Again integrating by part, we get I is equal to minus e power x cos bx divided by b plus a by b into applying by part integration on these two functions, e power ax sin bx, derivative of cos bx is sin bx divided by b, minus integration into again derivative of this function is sin bx divided by integration into integration of this function sin bx divided by b, and multiply by derivative of this function is e power ax is equal to e power ax into a d of x. Now multiplying a by b on all terms of this. Next, after multiplication, e minus e power x cos bx divided by b plus a over b square e power ax sin bx minus a square, this a over b multiplying then this a and this a become a square, this b and this b become b square into integration of e power ax sin bx into d of x. These all terms are same. Minus a square or b square, at the place of this we put I, because from equation number 1 this is equal to I, this is given question, okay, plus c1. Now move this term from right side to left side, its symbol will be changed from negative to positive. Now take LCM. LCM is here, LCM is b square. We get b square LCM, okay, b square multiplied by 1 is I is b square plus a square I, taking I as common, which is equal to e power ax divided by b square into minus b cos bx plus a sin bx plus c1 is a constant of integration. Okay, this b square is multiplying, dividing here. When we move from left to right side, it's multiplying by whole term. This b square and this b square and b square are cancelled out. We get b square plus a square I is equal to e power ax into a sin bx minus b cos bx plus b square c1. Okay, put a is equal to r cos theta, this a is equal to r cos theta and this b is equal to r sin theta. Squaring and adding these two terms, a square plus b square is equal to r square cos square theta plus r square sin square. Taking r square common, we know that cos square theta plus cos square theta is equal to 1. A square plus b square is equal to r square. Taking square root on both sides, we get r is equal to square root of a square plus b square. Now dividing these two terms, okay, we get b over a is equal to r sin theta over r cos theta. R and r cancel out, we get b over a is equal to tan theta, and theta is equal to tan inverse of b over a. Now putting the value of a, b, r and theta above, we get b square plus a square I is equal to e power ax into, at the place of a we put r cos theta sin bx minus at the place of b r sin theta into cos bx plus b square and c1. Okay, b square plus a square into I is equal to, taking common r from here, which is e power ax r into sin bx cos theta minus cos bx sin theta plus b square c1. Okay, now a square plus b square I is equal to e power ax r, this is r. This is a trigonometric function which is a sin bx minus theta. We know that sin alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. Here at the place of alpha is bx and at the place of beta is theta, so which can be written as sin bx minus theta plus b square c1. Putting value of r and theta. Now putting here the value of r and theta, we get e power ax, at the place of r we put square root of a square plus b square, and at the place of this, okay, sin bx minus at the place of theta is tan inverse of b over a plus tan b square c1. Okay, this square root a square plus b square is multiplying by 1 on left hand side. Move from left side to right side, we get I is equal to square root of a square plus b square over a square plus b square e power ax sin into bx minus tan inverse of bx plus this b square divided by a square plus b square into c1. Okay, this and this one is cancel because its power is 1 by 2. When move from numerator to denominator, its power become negative. These same function are multiplied and their powers are added, then we get square root of a square plus a b square e power ax sin bx minus tan inverse of b over a plus c. This whole function is called c because b square over a square plus b square is constant and c1 is constant. Constant multiply constant, again a constant, which is the required solution, which is equal to right hand side. Question number 4, part number 1. Let I is equal to integration of square root of a square minus x square d of x. Integration of square root of a square minus x square into 1 d of x. Okay, this is here we have just one function and its derivative, its integral is not possible because a derivative of a square is 0, but derivative of minus x square is minus 2x. Here minus 2x is not available. Okay, that's why we take another function which is 1. Now we have two functions. Now applying integration by integrating by part these two. Okay, this one is first function as it is square root of a square minus x square as it is. Integration of 1 is x minus integration into integration of second function which is x. dot derivative of first function square root of a square minus x square. Its derivative is taking power before this function 1 by 2 and a square minus x square whole power minus 1 by 2, because 1 by 2 minus 1, which is minus 1 by 2. And again the derivative of inner function is a square minus x square, which derivative is minus 2x. Okay, now simplifying this, we get x square root of a square minus x square minus this minus 2 and 2 is cancel out. We got minus x square over a square minus x square. We see in denominator we have a square minus x square, but in numerator we have minus x square. So we add here a square and also subtract by a square, adding and subtracting by a square. Okay, now divide this terms by a square minus x square and minus a over a square minus x square. Okay, first term is cancel out, this and its whole power 1 is cancel out. We get square root of a square minus x d of x plus integral 1 a square over square root of a square minus x square d of x. Okay, I is equal to x square root of a square minus x square minus this function become I from equation number 1. We know that I is equal to integral square root of a square minus x square d of x. Okay, plus a square into integration of 1 over square root of a square minus x square. These all function. This minus I shift from right to left, which its sign will be changed into positive. Okay, I into I is 2i, and we know the integration of 1 over square root of a square minus x square is sine inverse of x by a. Okay, now this 2 is multiplying here and we dividing both side by 2 and 2 cancel out. We get I is equal to 1 by 2 x square root of a square minus x square plus 1 by 2 a square sine inverse of x by a plus 1 by 2 constant of integration. A review. As we know that integration of dx upon square root of x square minus a square, which is equal to natural log of x plus square root of x square minus a square plus constant of integration, and also integration of dx upon square root of x square plus a square, which is equal to natural log of x plus square root of x square plus a square. Keep in your mind these formulas will be used in next question. Okay, question number 4, part number 2. Let I is equal to integral square root of x square minus a square, but derivative of this inner function is 2x. 2x is not available here, that's why we take another function which is 1. Okay, now applying by part integration. First function we take square root of x square minus a square, which is same. Integration of second function which is 1. Integration of 1 is x minus integral into integration of second which is x. Okay, derivative of first taking power rule. Okay, 1 by 2 into x square minus a square whole power minus 1 by 2 taking derivative of inner function which is equal to 2x. Its negative power will become positive when we move from numerator to denominator. Okay, next derivative of here we can see x square minus a square, but here only we have x square, so adding and subtracting by a square. X square minus a square plus a square. Now divide this term by x square minus a square plus a square. Okay, this x square minus a square whole power 1 by 2 is cancelled out from this a square from whole power of this function. Okay, we get integration of square root of a square minus x square plus integration of a square upon square root of a square minus x square. I is equal to x square root of a square minus x square minus, at the place of this function we put I. Okay, from equation number 1 we know that I is equal to integration square root of a square minus x square plus a square, as it is integration of 1 over square root of a square minus x square d of x. Okay, the shift this minus I from right to left, we get I plus I, which is equal to x square root of a square minus x square plus a square. We know that the integration of 1 over square root of a square minus x square is sine inverse of x by a plus a constant of integration. I and I is 2i. This 2 is multiplying here. We divide both sides by 2. We get I is equal to 1 by 2 x square root of a square minus x square plus 1 by 2 a square sine inverse of x by a plus 1 by 2 constant of integration. Part number 3 is let I is equal to integration of square root of 4 minus 5 x square d of x. Derivative of inner function is minus 5 to 10x minus 10 which is not available here. That's why we take another function which is 1. So we have two functions. Now applying by part integration on these two functions. First function we take here square root of 4 minus 5x here. First function as it is multiply by integration of second function was integration of 1 is x minus integral into integration of second is 1, its integration is x, and derivative of first which is 1 by 2 into 4 minus 5 x square whole power minus 1 by 2, and the derivative of inner function we get minus 10x d of x. Next square root of 4 minus 5x square into x as it is minus integration of minus 5x square divided by 4 minus 5x square d of x. Okay, this 2 and this 10 is cancelled out, we get minus 5x square. In a denominator we can see 4 minus 5x square, but in numerator we have minus 5x square. That's why we add here 4 and also subtracting by 4. Adding and subtracting by 4 of numerator we get this term. Now divide this by 4 minus 5x square and minus 4, we get this one. Now these two terms are cancelled out, and then take integral. This and this terms, power of these terms are cancelled out, and we get integration of square root of 4 minus 5x square d of x plus this 4 is a constant, so we take outside the integral. Integration of 1 over square root of 4 minus 5x square d of x. This whole function become equal to minus I from equation number 1. We know that I is equal to integration of square root of 4 minus 5 x square plus 4. Now take common 5 from here. Taking common 5, we get 4 by 5 minus x square. Okay, which is a constant value. Square root of 5 take outside the integral, and here we take square of 2 also square root of 5 whole square. This square and square root cancel over, we get again 5. Okay, which is same as 1 over which one is same as 1 over square root of a square minus x square, and we know that if we have integration 1 over square root of a square x square which is equal to sine inverse of x by a. That's why square root of a 4 minus 5x square multiplied by x plus 4 over square root of 5 as it is into sine. This whole function becomes sine inverse of x over divided by 2 square root of 5. Okay, this integration of dx upon square root of a square minus x square always equal to sine inverse of x by a. Here at the place of x is x, and at the place of a is 2 over square root of 5. Now this square root of 5 shift from the denominator to numerator form, we get this one. Okay, this 2 and 4 are cancelled out, we get 2 over square root of 5, where this 1 by 2 into c1 is equal to c is the required solution. Question number 4 part number 5 same as question number 4 part number 2. Okay, we have already solved this question. Question number 4 part number 6 is also same to question number 2 part number 5. Important formulas. Here we use just only this formula. If integration of e power ax into a f of x plus f prime of x d of x, which can be written as e power ax f of x plus constant of integration. को हम लेफ्ट साइड को लेट कर लेते हैं, इसको लेट कर लेते हैं किसके इक्वल, आई के इक्वल. आई इज इक्वल टू इंटेग्रल ई पावर एक्स इंटू 1 ओवर एक्स प्लस नेचुरल ऑफ एक्स इंटू डी ऑफ एक्स. ये आ गया हमारे पास. इसको हमने इंटीग्रेट करना है. अच्छा, इसको चलिए हम एक तरतीब से लिख लेते हैं कि नेचुरल ऑफ एक्स प्लस 1 और एक्स को बाद में लिख लेते हैं, नेचुरल ऑफ एक्स को हम पहले लिख लेते हैं. ठीक, यहाँ पर ये एक हमें बताते हैं कि अगर हम नेचुरल ऑफ एक्स को लेट कर लेते हैं सपोज किसके इक्वल, एफ ऑफ एक्स के ऊपर, तो इसकी जगह पुट करते हैं एफ ऑफ एक्स, तो हम जानते हैं कि नेचुरल ऑफ एक्स का डेरिवेटिव क्या हो जाएगा, 1 ओवर एक्स. एफ प्राइम ऑफ एक्स किसके इक्वल आ जाएगा 1/x की। इसका मतलब इसको एफ ऑफ एक्स रखते हैं तो ये बन जाएगा एफ प्राइम ऑफ एक्स। तो देखिए ई पावर एक्स एज इट इज, पहला जो नेचुरल ऑफ एक्स था उसकी जगह एफ ऑफ एक्स प्लस दूसरे की जगह हमने लिख लिया एफ प्राइम ऑफ एक्स डी ऑफ एक्स। अगर आप गौर से देखें इसे तो हमारे पास ये जो है ई पावर एक्स को अगर अंदर मल्टीप्लाई करें, मैं लेता हूँ स्क्रीन एक और शेयर करता हूँ, ई पावर एक्स एफ ऑफ एक्स प्लस सी। तो हम दोबारा से ई पावर एक्स नेचुरल ऑफ एक्स प्लस सी लिख लेंगे, जो एफ ऑफ एक्स था उसकी जगह वापस क्या पुट कर लेंगे हम नेचुरल ऑफ एक्स। उसकी वैल्यू है कि इंटीग्रल ई पावर एक्स कॉस ऑफ एक्स प्लस साइन ऑफ एक्स। तो देखें इसको भी तरतीब से हमने लिख लिया कि साइन एक्स को हम पहले लिख लेते हैं और कॉस एक्स को बाद में लिख लेते हैं। तो उसके बाद हमने ये काम किया कि फर्स्ट जो साइन एक्स था उसको हमने लेट कर लिया किसके इक्वल एफ ऑफ एक्स के इक्वल, और इसका अगर डेरिवेटिव लेते तो एफ प्राइम ऑफ एक्स आ जाएगा कॉस ऑफ एक्स, साइन एक्स का डेरिवेटिव होता है कॉस एक्स। इनको वापस यहाँ पुट करते हैं तो देखिए साइन एक्स की जगह हमने लिख लिया एफ ऑफ एक्स और cos x की जगह हमने लिख लिया एफ प्राइम ऑफ एक्स। अगर इस e पावर x को अंदर मल्टीप्लाई करते हैं हम तो हमारे पास e पावर x एफ ऑफ एक्स प्लस e पावर x एफ प्राइम ऑफ एक्स। तो ये बन जाएगा हमारे पास दो फंक्शन और दो फंक्शन का प्रोडक्ट रूल लग जाएगा। मीन फर्स्ट फंक्शन एज इट इज डेरिवेटिव ऑफ सेकंड प्लस सेकंड एज इट इज डेरिवेटिव ऑफ फर्स्ट। तो असल में ये फंक्शन होंगे दोनों e पावर x एफ ऑफ एक्स। इसको देखें, इसको फर्स्ट फंक्शन मान के चलते हैं, इसको सेकंड। तो फर्स्ट फंक्शन आ जाएगा हमारे पास एज इट इज डेरिवेटिव ऑफ सेकंड e पावर x का डेरिवेटिव वापस e पावर x या ऑफ x का डेरिवेटिव आ जाएगा एफ प्राइम ऑफ एक्स और e पावर x एज इट इज आ जाएगा। तो वो इंटीग्रल और डेरिवेटिव कैंसिल हो जाएगा तो हमारे पास आ जाएगा e पावर x एफ ऑफ x प्लस कांस्टेंट ऑफ इंटीग्रेशन। में हमसे कहा गया कि लेट I इज इक्वल टू इंटीग्रल e पावर ax a secant इनवर्स ऑफ x प्लस 1 ओवर x स्क्वायर ऑफ x स्क्वायर माइनस 1। तो देखिए हम जानते हैं कि हमने यहाँ पर पुट कर लिया किसको सेकेंड इनवर्स ऑफ x को किसके इक्वल एफ ऑफ एक्स के इक्वल, और एफ प्राइम ऑफ एक्स किसके इक्वल होता है, अगर सेकेंड इनवर्स ऑफ एक्स का डेरिवेटिव होता है हम जाते हैं 1 ओवर x स्क्वायर ऑफ x स्क्वायर माइनस 1। तो अब देखिए कि एक फंक्शन ये है, दूसरा फंक्शन हमारे पास है ये मौजूद है, ठीक है। और ये e पावर x को अगर अंदर मल्टीप्लाई करें तो फर्स्ट फंक्शन सेकंड इनवर्स ऑफ x एज इट इज डेरिवेटिव ऑफ सेकंड e पावर x का डेरिवेटिव वापस क्या रहेगा e पावर x इनटू पावर का डेरिवेटिव लेंगे तो हमारे पास क्या देगा a आ जाएगा, ठीक है ना। ये साथ में लिखा हुआ है तो इसकी जगह वापस पुट कर लिया एफ ऑफ एक्स प्लस एफ प्राइम ऑफ एक्स इंटू डी ऑफ एक्स। इसको क्लोज करके लिखे तो हमारे पास जगह ई पावर डी अपॉन डी एक्स ई पावर ए एक्स इंटू एफ ऑफ एक्स प्लस सी। तो इंटीग्रल और डेरिवेटिव कैंसिल हो जाएगा तो हमारे पास ये बच जाएगा और एफ ऑफ एक्स की वैल्यू हमें वापस पुट कर देंगे 3x इंटू 3 साइन एक्स माइनस कॉस एक्स डिवाइडेड बाय साइन स्क्वायर एक्स। हम ये काम कर लेते हैं साइन स्क्वायर एक्स को डिवाइड कर लेते हैं 3 साइन एक्स माइनस कॉस एक्स से, दोनों से हमने इसे क्या कर लिया है डिवाइड कर लिया है अलग अलग। तो हम यहाँ पहुंच गए तो इससे कैंसिल हो जाएंगे कुछ, अच्छा जो कैंसिल होने के बाद हमारे पास बचा 1 ओवर साइन एक्स माइनस कॉस एक्स डिवाइडेड बाय साइन स्क्वायर एक्स था तो उसको हमें ब्रेक करके लिख लिया साइन एक्स इंटू साइन एक्स। तो 1 ओवर साइन एक्स किसके इक्वल होता है विच इज इक्वल टू कोसिकेंट एक्स, दिस इज इक्वल टू कोसिकेंट एक्स एंड 1 ओवर साइन एक्स क्या हो जाएगा कोसिकेंट एक्स और कॉस ओवर साइन एक्स इक्वल हो जाएगा कॉट एक्स इंटू डी ऑफ एक्स। अब हम देखते हैं कि अगर हम फर्स्ट फंक्शन जो इसको मान के चलते हैं एफ ऑफ एक्स लेट कर लेते हैं किसको सेकंड एक्स को एफ ऑफ एक्स, तो एफ ऑफ एक्स का डेरिवेटिव आ जाएगा एफ प्राइम ऑफ एक्स विच इज इक्वल टू माइनस कोसिकेंट एक्स कॉट एक्स। इसका मतलब अगर एक ये फंक्शन एफ ऑफ एक्स है तो एफ ऑफ एक्स का डेरिवेटिव हमारे पास मौजूद है और साथ ई पावर 3x एक्सपोनेंशियल मौजूद है। तो इसको हम क्लोज करके लिख सकते हैं वापस ई पावर 3x एफ ऑफ एक्स इन डी एफ एक्स इंटू इंटीग्रल। तो इंटीग्रल डेरिवेटिव कैंसिल हो जाएगा तो हमारे पास है ये बन जाएगा एफ ऑफ एक्स की जब वापस उसकी वैल्यू पुट करनी। माइनस वाली जो टर्म थी माइनस साइन एक्स इसको हम बाद में लिख लेते हैं और प्लस वाली को हम पहले लिखते हैं। कॉस एक्स को हम मान के चलते हैं कि कॉस एक्स क्या है एफ ऑफ एक्स के इक्वल, इसको पुट कर लेते हैं और फिर उसका डेरिवेटिव लेते हैं। तो हम जानते हैं कि कॉस एक्स का डेरिवेटिव होता है माइनस साइन एक्स। तो देखें यहाँ पर माइनस साइन एक्स मौजूद है, हम ये देखें 2 एफ ऑफ एक्स प्लस एफ प्राइम ऑफ एक्स लिखते हैं, इसको क्लोज करके लिखते हैं तो ई पावर 2x एफ ऑफ एक्स इंटीग्रल डेरिवेटिव लेंगे वो कैंसिल हो जाएगा तो हमारे पास ये बच जाएगा एफ ऑफ एक्स की वैल्यू वापस पुट कर ले ई पावर x डिवाइडेड बाय 1 प्लस एक्स स्क्वायर। अब मसला ये है इस क्वेश्चन में कि ऊपर ये x ई पावर x है, नीचे जो है 1 प्लस एक्स का होल स्क्वायर है, इसका डेरिवेटिव ऊपर मौजूद नहीं है। लिहाजा हमने ये काम किया कि ये जो x था इस x के साथ हमने 1 को ऐड और सब्ट्रैक्ट कर लिया, ठीक है। ये 1 और इस x के साथ 1 ऐड भी किया सब्ट्रैक्ट। अब देखते हैं हमारे पास दो फंक्शन बनेंगे, इस 1 प्लस एक्स का होल स्क्वायर को 1 प्लस एक्स से डिवाइड कर लें और -1 से अलग डिवाइड कर लें, ई पावर एक्स को हम शुरू में ले लेते हैं बाहर, ठीक है। तो ये कैंसिल हो जाएगा और एक इसकी पावर कैंसिल हो जाएगी, तो हमारे पास ये बच जाएगा। इनटू दिस हम पहले को लेट कर लेते हैं एफ ऑफ एक्स के इक्वल और इसको ऊपर ले जाते हैं, इसकी पावर नेगेटिव हो जाएगी और इसका जब डेरिवेटिव लेते हैं प्राइम ऑफ एक्स, पावर शुरू में आ जाएगी, पावर से कम करेंगे ये आ जाएगा, इसकी पावर नेगेटिव थी तो हम इसको लिख सकते हैं 1/1 प्लस एक्स का होल स्क्वायर, ठीक है। तो अब देखें अगर, तो ये वापस वो फंक्शन बन चुका है हमारे पास ऊपर जो हमें चाहिए था, तो जो ऊपर है उसकी जगह हम एक्स लिख लेते हैं। अच्छा, गिवन जो फंक्शन था ई पावर एक्स एज इट इज इनटू, जिसको ये जो लेट किया इसकी जगह हम लिख लेते हैं एफ ऑफ एक्स और दूसरे की जगह हम लिख लेते हैं क्या चीज, एफ प्राइम ऑफ एक्स में बाल पॉइंट ले इनटू इसको क्लोज करके अगर लिखें तो ई पावर एक्स इनटू डी ओवर डी एक्स ई पावर एक्स इनटू एफ ऑफ एक्स इनटू डी ऑफ एक्स आएगा, तो इंटीग्रल डेरिवेटिव क्या हो जाएगी, कैंसिल। हमारे पास ये बच गया एफ ऑफ एक्स की वैल्यू वापस हमने पुट कर एक्स इनटू कॉस एफ एक्स माइनस साइन ऑफ एक्स। तो ये किया इन्होंने कि cos x का डेरिवेटिव जो कि माइनस साइन एक्स था, इसमें प्रॉब्लम ये थी कि एक्सपोनेंशियल की पावर भी क्या है, नेगेटिव है, इसलिए इन्होंने ये काम किया ई पावर x -1 इंटू साइन एक्स, मीन माइनस साइन एक्स भी आप दूसरे लफ्ज में कह सकते हैं, लिख सकते हैं, प्लस cos x को बाद में लिख लिया, ये टर्म पहले लिख लिया माइनस वाली और प्लस वाली बाद में लिख लिया। पहले को हमने लेट कर लिया किसके इक्वल, साइन एफ एक्स के, एफ ऑफ एक्स इक्वल टू साइन एफ एक्स, उसका डेरिवेटिव लें तो वापस cos एफ एक्स आता है, ई पावर एक्स एज इट इज इनटू -1 जगह पे साइन एक्स की जगह लिख लिया एफ ऑफ एक्स प्लस cos एक्स की जगह लिख लिया एफ प्राइम ऑफ एक्स। इसको अगर क्लोज करके लिखें तो डी ओवर डी एक्स इनटू ई पावर माइनस एक्स एफ ऑफ एक्स डी ऑफ एक्स प्लस इंटीग्रल, और जब वो कैंसिल हो गया तो साथ क्या आ जाएगा, कांस्टेंट ऑफ इंटीग्रेशन, और एफ ऑफ एक्स की वैल्यू हमने वापस पुट कर लिया। नंबर 8 में हमसे पूछा गया है कि I is equal to, let I is equal to e power mx e power m tan inverse of x divided by 1 plus x का होल स्क्वायर, ठीक है। अच्छा, इसको हम यूं भी लिख सकते हैं, ये जो टर्म है डिवाइड और लिहाजा इसको लिख सकते हैं डॉट की फॉर्म में, मीन मल्टीप्लाई बाय 1 ओवर e पावर माइनस e पावर m tan इनवर्स ऑफ x इनटू 1/1 प्लस एक्स के हमने लिख लिया, ठीक। अच्छा, इस फंक्शन को, ये जो पावर में फंक्शन है tan x, इसको हमने पुट कर लिया इक्वल t के इक्वल, तो डी ऑफ टी क्या आ जाएगा हमारे पास, पता है हमें कि tan इनवर्स ऑफ x का डेरिवेटिव होता है 1/1 प्लस एक्स के इनटू डी ऑफ एक्स। इनको वापस इधर पुट कर लेते हैं यहाँ पर सब वैल्यूज को, तो हमारे पास आ जाएगा e पावर m t इनटू डी ऑफ टी। अच्छा, तो उसका डेरिवेटिव इंटीग्रल लेंगे हम, तो हमें पता है कि एक्सपोनेंशियल फंक्शन का जब भी इंटीग्रल लिया जाए वापस वो आता है e पावर m t का इंटीग्रल आ जाएगा e पावर m t, और जो कांस्टेंट है पावर में m, तो उसी से क्या कर लेंगे हम, डिवाइड कर लेंगे प्लस कांस्टेंट ऑफ इंटीग्रेशन, और t की जगह वापस t की वैल्यू पुट कर लेंगे विच इज tan इनवर्स ऑफ x। हम क्या लिख सकते हैं, हम लिख सकते हैं sin x डिवाइडेड बाय cos x। तो लेट कर लेते हैं या पुट कर लेते हैं हम cos x को किसके इक्वल, t के इक्वल, तो इसका डेरिवेटिव लेते हैं, तो डेरिवेटिव इसका आ जाएगा माइनस साइन एक्स डी ऑफ एक्स, तो माइनस को इस साइड पे ले आए तो हमारे पास आ जाएगा माइनस डी टी इज इक्वल टू साइन एक्स डी एक्स। अगर वापस यहाँ पुट करें तो हमारे पास हम ऊपर क्वेश्चन में अगर पुट करते हैं तो साइन एक्स डी एक्स की जगह हम क्या लिख लेंगे, साइन एक्स डी एक्स की जगह माइनस टी आ जाएगा हमारे पास, ये देखें, और नीचे जो cos था हमारे पास उसकी जगह आ जाएगा t, माइनस को बाहर लेते हैं तो ये t जो होता है फंक्शन t का डेरिवेटिव विद रिस्पेक्ट टू t1 आता है, तो इसका डेरिवेटिव मौजूद है, लिहाजा इसके साथ क्या लग जाएगा, नेचुरल लॉग। तो इस तरह ये माइनस शुरू में जो होता है ना, इस t की जगह वापस पुट कर ले cos x, तो नेचुरल लॉग से कोई भी फंक्शन नंबर पहले हो तो उसको हम पावर में ले जा सकते हैं, ये -1 है हमारे पास, इसको हम पावर में ले जाएंगे, और ये पावर होल पावर है ऐसे में, तो ये पावर नेगेटिव है, तो cos की पावर नेगेटिव है, इसको 1 से डिवाइड कर लेंगे पॉजिटिव आ जाएगा, तो इसकी जगह हम वापस लिख सकते हैं क्या, secant x, इसका मतलब इंटीग्रेशन ऑफ tan x d ऑफ x होती है नेचुरल लॉग ऑफ secant x प्लस c। लेट i इज इक्वल टू इंटीग्रल 2x डिवाइडेड बाय 1 माइनस साइन x। तो देखें यहाँ पर इसको हम करते हैं रेशनलाइज, मतलब जो डिनोमिनेटर है इसी से मल्टीप्लाई और डिवाइड करते हैं, और दरम्यान में क्या ले लेते हैं, सिंपल साइन प्लस कर लेते हैं, उधर माइनस का था इसलिए, ठीक। तो नीचे हम इस एक फंक्शन ये है, दूसरा ये, इन दोनों ये प्रोडक्ट हो रहे हैं, हम मान के चलते हैं कि ये a माइनस बी इंटू ए प्लस बी है, तो वो होता है a स्क्वायर माइनस बी स्क्वायर, तो 1 मल्टीप्लाई बाय 1 आ जाएगा क्या, 1 का स्क्वायर माइनस साइन इंटू साइन स्क्वायर आ जाएगा, ठीक है। ऊपर 2x को क्या कर लेते हैं, मल्टीप्लाई कर लेते हैं। अब 1 माइनस साइन स्क्वायर x किसके इक्वल होता है, हम जानते हैं होता है cos स्क्वायर x के, cos स्क्वायर x के इन दोनों फंक्शन से अलग अलग क्या कर लें, डिवाइड कर लें, हमारे पास आएगा 2x डिवाइडेड बाय cos स्क्वायर x, प्लस 2x साइन एक्स डिवाइडेड बाई कॉज स्क्वेयर एक्स। तो ये जो फर्स्ट फंक्शन है इसको हमारे पास 2 क्या हो जाएगा, कॉमन ले लेंगे बाहर, 2 लिया बाहर कॉमन, तो x एज इट इज रख लिया हमने ये, और 1 और कॉस स्क्वायर एक्स आ जाएगा सेकंड स्क्वायर एक्स। इसके बाद ये जो कॉस स्क्वायर एक्स था इस कॉस स्क्वायर एक्स को इधर ब्रेक करके लिखा हमने, तो 2 बाहर आ गया, कांस्टेंट था x एज इट इज, तो 1 ओवर cos x आ जाएगा सेकंड x, और ये sin x और ये जो नीचे एक cos x है ये बन जाएंगे हमारे पास है tan x। अब चूंकि फंक्शन बन गया हमारे पास दो दो, इधर भी फंक्शन दो है उधर भी दो है, तो लिहाजा हम ये काम करते हैं कि इसके ऊपर बाई पार्ट इंटीग्रेशन लगाते हैं। ठीक है, तो बाई पार्ट इंटीग्रेशन कुछ इस तरह से है, इंटीग्रेटिंग बाई पार्ट। तो हमारे पास आ जाएगा फर्स्ट फंक्शन है x और सेकंड फंक्शन है हमारे पास सेकेंड x। फर्स्ट फंक्शन एज इट इज, डेरिवेटिव ऑफ सेकंड, सेकंड स्क्वायर x का सॉरी इंटीग्रेशन ऑफ सेकंड, सेकंड स्क्वायर x की इंटीग्रेशन होती है tan x माइनस फार्मूले का इंटीग्रेशन इनटू इंटीग्रेशन ऑफ सेकंड, सेकंड स्क्वायर x की इंटीग्रेशन आ गई है tan x डॉट डेरिवेटिव ऑफ फर्स्ट, तो फर्स्ट है 1x, तो x का डेरिवेटिव आ जाएगा 1 इंटू डी ऑफ x, प्लस यहाँ पर हम लेते हैं फर्स्ट फंक्शन एज इट इज, फर्स्ट फंक्शन है x इंटीग्रेशन ऑफ सेकंड एक्स टेन एक्स, इस पूरे की याद रखना, इंटीग्रेशन होती है सेकंड एक्स टेन एक्स की, क्या इंटीग्रेशन होती है सेकंड एक्स, क्योंकि हमने डेरिवेटिव पढ़ा हुआ है कि सेकंड एक्स का डेरिवेटिव होता है क्या, सेकंड एक्स से टेन एक्स, जैसा उसकी इंटीग्रेशन लगे तो वापस सेकंड एक्स माइनस फॉर्मूले का इंटू इंटेग्रल इंटू इंटीग्रेशन ऑफ सेकंड एक्स टेन एक्स अगेन इज सेकंड एक्स, और डेरिवेटिव ऑफ एक्स इज 1 इंटू डी ऑफ एक्स। ठीक है, यहाँ से हम इसके बाद ठीक है ओके, फिर बिल्कुल ये सेम फंक्शन रहेंगे, 2 कॉमन ले लेते हैं बाहर, ये सेम आ गया, और हम जानते हैं ऊपर हम पढ़ चुके हैं कि इंटीग्रेशन ऑफ सेकंड एक्स टेन एक्स क्या होती है, नेचुरल लॉग ऑफ सेकंड एक्स। ठीक है, और यहाँ पर हम जानते हैं कि इंटीग्रेशन जो होती है सेकंड एक्स की, बाकी सारा बिल्कुल सेम रखेंगे, इंटीग्रेशन सेकंड एक्स की होती है नेचुरल लॉग ऑफ सेकंड एक्स प्लस टेन एक्स प्लस कांस्टेंट ऑफ इंटीग्रेशन, और इनमें से ये जो 2 था इसको अंदर मल्टीप्लाई किया तो हमने ये लिख लिया इसका आंसर। तो इंशाल्लाह रिमेनिंग क्वेश्चन हम नेक्स्ट लेक्चर में करेंगे। थैंक्स फॉर वाचिंग, अल्लाह हाफिज़, गुड लक।